So welcome to today's webinar. We'll be running a live Q&A at the end of the webinar. If you have any questions, please feel free to go ahead and ask your questions in the chat, and we will answer them at the end of the webinar. And if you miss anything, don't worry. We'll be sending a recording as soon as it's available. So today, we're going to be discussing the new 13.3 release of Tom Sawyer Perspectives. So I'm going to share my screen here, and we're looking at the results of our new Kuzu integration in Tom Sawyer Perspectives. And today we have our special guest, Dr. Semih Salihoğlu, who's going to be discussing the Kuzu database. And then we will take a look to see how do you use the new Kuzu integrator in Tom Sawyer Perspectives. We'll also be discussing our improvements to our modern React-based web client framework and our circular layout algorithm. Then we will take a quick look at a new example application that we have. And so with that, I'm going to hand this over to Semih, who is going to tell us more about the Kuzu database. Thank you, Semih. We're so happy that you're here today.
So I'll start by giving an overview of Kuzu, which is a modern new graph database engine that we're developing. The system, so I'm a professor, so I'm CEO of Kùzu Inc, which is the company that's commercializing Kuzu, but I'm also a professor at University of Waterloo, and Kuzu is a spin-off from my research group, and we've been a company for about 2.5 years now. So there's been a lot of development and lots of production uses of Kuzu. So it's a quite stable technology at this point. So let me tell you kind of what are the core features that I'd like to highlight about Kuzu. So the first is it's a state-of-the-art modern property graph database management system. So we implement Cypher, and I'll give you a one-slide overview of our data model and query language. And second is that we're a system that can run pretty much anywhere on any CPU, but also in any computing environment. And I'll tell you about that. And our kind of one motto that I use to explain this is that we'd like people to be able to query their graphs and vectors from everywhere. And I'll kind of talk about this as well. And the third is that Kuzu can be a solid foundation for especially the modern AI applications that you might be building, because we have not only a sort of a state-of-the-art graph database and the storage and indices for that, but also a vector index, native vector index, and also a full text search index. So you can store both your structured records in the form of a graph, as well as your text and unstructured vectors also in Kuzu. So let me start by giving an overview of the data model and the query language of the system. So I'll assume some familiarity with graph databases here. So this will be brief. So the model is based on the property graph data model, but we call it structured property graph model because the schema is defined upfront. So the way you define your schemas is with these DDL statements like creating node or relationship tables. So what I mean is that when I say schema is upfront, is that you need to tell us your records and their structure. So the data type of each of the properties you store on your nodes and edges a priori before you can actually ingest data into Kuzu and query them. So here I'm showing you how to create an accounts table and a transfers accounts node table. Maybe those are your entities with account ID and balance properties, and you do identify for your nodes the primary key of that node, and transfer edges for which you have to identify between what types of nodes and what types, from which types of nodes to which types of nodes. And you can also put some properties on them, but you have to define the schema up front. And the query language of the system is OpenCypher. So we do implement, and we're comprehensive about our OpenCypher's coverage at this point. So it's match, where, return type of statements that you use. Okay. So the first property that I wanted to highlight is that Kuzu is a system that is designed to run everywhere. And what I mean by this is that, first of all, it's a single binary with no external dependencies. So you don't have to a priori install anything else to use Kuzu. The second is that we are not a server client system, at least the open source version of Kuzu that you can have access right now. And it's an in-process library. So think of like if you're familiar with SQLite, or a more modern version is DuckDB. If you're following the DuckDB wave, DuckDB has kind of reminded people the utility of having these extremely easy to use libraries, database libraries, where you get a full-fledged database functionality, but it's a library that you just import with a single line. So that's why for people who are familiar with DuckDB, we like explaining Kuzu. Think of DuckDB, but it's Cypher. Okay, so think of DuckDB for graphs. Okay, so here I'm showing you an example, an example of how you would end up using Kuzu and developing essentially an application in Python. So first of all, the installation is just one line. Pip install Kuzu, and that gets you Kuzu. And now you can actually, with a single inside your Python script, with a single import Kuzu, start creating Kuzu databases and issuing some Cypher queries. So because we are in process, because we are embedded like DuckDB and SQLite, what that means is that we are part of this Python script basically. Kuzu runs as part of that Python script. Okay. So I want to highlight this a little bit. This is, I think, a major paradigm shift, like using a graph database this way, or in general, using a database this way compared to the traditional server client architecture. And I want to highlight the advantages of this. So here I'm showing you the traditional two-tier architecture of how people develop database applications. So the way traditional architecture is that there's a database server that's running somewhere. Okay, it's this monolithic process that's running somewhere in your cluster. And then you most often put an app server in front of it, maybe a node server. And then in front of it, and in modern applications, this app server could also be essentially maybe getting some data from a data lake. And there will be some applications in front of the app server that talks to the database server through the app server. So this is the traditional two-tier architecture since maybe late 1980s, 1990s. This is how database applications are built. Now with a system like Kuzu, first of all, there is no server. Okay, so the server component goes away. So you might keep this type of architecture if you want, but you don't have to. So the first thing, for example, you can do is that you can put Kuzu directly inside your app server. So why is that might be a good idea? Because traditionally in this previous architecture, when your loads increase and decrease, you have to think of two things. You have to think of how to increase your database servers up and down, as well as your app server up and down. So there's the kind of like two sort of concerns that you have. With a system like Kuzu, because we are bundled as part of the app server, now you can actually scale only the app server up and down, and that kind of takes care of your load increases and decreases, right? The second thing is in the modern sort of data analytics ecosystem, there's other environments in which people want to do data analytics. So for example, you can put Kuzu inside a serverless Amazon Lambda function. Okay, or also Microsoft Azure has these sort of serverless functions. We are a system that runs directly inside that serverless functions, and we're the only graph database that can do this. And why is this a good idea? This is a good idea because first of all, you might be doing certain analytics in an ephemeral way. Maybe you don't want to persist your data, you want to do it on the fly. So maybe you have your Parquet files here and you want to directly ingest it quickly into some sort of script and then do some analytics and then throw the results of that. Don't necessarily maintain or persist the database, but then sort of put the results somewhere back into the data lake. Okay. Second, serverless functions are a lot cheaper than maintaining these servers that are burning cache if you're doing the traditional architecture. And further, you could put us directly into your desktop app, so we can run on your laptop. So like a lot of Python scripts people use on their local computers. You can put us into your mobile applications. We run in mobile applications and even inside your browser. So it is a kind of like an important paradigm shift, right? And you can use Kuzu, like this is what I meant by like we're a system that runs everywhere. And in no matter where we run, it's always the same binary that's running. It's always the same database files. So if you're persisting your databases into some local files or S3, let's say, it is the same kind of exactly the same format, no matter where you use Kuzu, right? So I want to sort of clarify a couple things. When I explain Kuzu as this in-process database, a lot of people associate it with us being in memory. And in fact, I did give an example where in a serverless Lambda function use case, you might actually be in memory. You might not want to persist things. But the fact that we are in process does not mean we're necessarily in memory. Actually, by default, Kuzu databases are persisted to a file. So we will persist your databases just like any database management systems use, but we do have this in-memory mode if you don't want to maintain your database. Okay, so that's kind of like an option that you have. If you got applications that don't need to persist the databases, you can do that with Kuzu as well using our in-memory mode, which will obviously also make your applications faster, right? The second is that a lot of people, because we are in process, associate Kuzu as being a system designed for small data. That's also not true. These are also very orthogonal properties, like how you deploy Kuzu, the open source version of Kuzu at least. The fact that it's a library doesn't mean that it can't handle small data. In fact, the story of Kuzu as a system, as a company, is that for 7 years prior to spinning off a company, we did work only on this problem of how do we build a modern graph database that can handle a lot of data and that's fast on a lot of data. So I actually do want to encourage people to use Kuzu, especially on large databases. I think of like billions of records that you want to ingest and do some kind of graph queries on top of it. And here I'm showing you links to all these years of research that we did exactly on this problem. How do we handle the scale problem? So we especially shine on large scale. So do not associate the fact that we are in process with the fact, with this misinformation or like misassociation that we can only handle small data. We can easily handle large data. And here's an example that I like showing people. This is an experiment demonstrating our data ingestion speed on the largest, essentially, graph database in the LDBC graph analytics benchmark that has 17 billion edges and half a billion nodes, roughly half a billion nodes. And then in Kuzu format, this takes about half a terabyte of database, and we can ingest this on this AMD processor, which is only $70. It's a very cheap processor. A lot of sort of clusters have much better processors than this, and we can do that with less than an hour. And nothing out there, no other product out there can have achieved these ingestion speeds. And similarly, we have excellent query speeds on this large scale. Okay, so on large scale, we especially shine. Another property that I want to highlight is that we are a very data science friendly, especially Python friendly database. What I mean by this, and I'll give a better example in the next slide, is that we integrate very well with a lot of sort of Python, other Python libraries. So you can seamlessly ingest data from, like, say, pandas, arrows, or PyArrow or polars directly into Kuzu, as well as obviously other kind of file formats like Parquet, Iceberg, Delta Lake. You can easily ingest data. We can scan directly. You can also scan Postgres, SQLite, and DuckDB natively. So you can directly attach to a Postgres database and scan some Postgres tables to move them into Kuzu. And once you do your Cypher queries in Kuzu, we have a convenience, essentially, functions that will convert them very easily into other libraries, data science libraries like Pandas, NumPy, or if you're using advanced Python graph analytics libraries like NetworkX, or graph machine learning or LLM libraries, we can have these convenience functions that make it seamless for you to move in, essentially, data in different formats into Kuzu and output the results of your queries into other formats. So here's actually one of the most popular sort of styles in which people use Kuzu in the Python ecosystem. So in this use case, there's a multi-step data analytics pipeline that in some steps will use Kuzu, but in some other steps will use other kind of Python libraries. So in this case, I'm showing you an example that uses Kuzu, Pandas, and NetworkX. And you might start with some maybe using Pandas to ingest your data and do some data frame operations. And now this connect execute, this is actually Kuzu code. So you're actually running Kuzu Cypher here. So you can ingest that data frame into a Kuzu node table, let's say, and because we are running as part of the same process, we are a library, we can actually do 0 copy scans of this data frame. So it's actually really efficient. And once you run your Cypher queries, you can seamlessly return the results of that query as a NetworkX object. Suppose, we have our own graph data science library, but, NetworkX is much more extensive than Kuzu graph sort of data science library. So maybe there are some algorithms that you want to run there. Well, PageRank isn't a good example because you can also do that directly in Kuzu, but, for whatever reason, you might want to do certain things in network X, get those results again, move that back into a data frame and give that back into Kuzu. So there's this, if you look at this code, there's a seamless kind of scanning of Python objects and outputting Python objects in and out of Kuzu. And this is what I mean by being a Python friendly or especially data science friendly library. And the last sort of feature that I want to highlight, which is where I was saying that Kuzu can be a solid foundation for some AI applications. One common property of those AI applications is the need to essentially process and query unstructured data, either in the form of some vectors or directly as text. And here I'll show you our vector index capability. So we have our natively built native vector index, so it's not like a dependency to Elasticsearch or Lucene. And it's disk-based, so we can scale out of memory. So you can store a lot of vectors in Kuzu. And to explain some of the unique capabilities, let me just demonstrate a running example. So suppose you have a set of documents, and these documents you have chunked, as a lot of kind of LLM-based agentic applications do, and maybe you embedded those chunks into some vectors, and maybe you also extracted some entities out of these documents. So maybe this person Alice is being mentioned in these chunks. Maybe these chunks mention Alice, and these two chunks mention Bob, so on and so forth. Okay, so you've done some entity extraction. Now you can model all of this data in Kuzu with the following schema. So you can have chunk nodes that will store the string contents as well as the vector embeddings of those contents, which we are assuming is done outside of Kuzu. And you have this person nodes, and you have this mentions edges, where each chunk that mentions a person gets an edge, mentions edge from that chunk to the person, right? So maybe this is your schema, and this could be your data, where your chunks are the red nodes and your person nodes are the blue nodes, and there are mentions edges between them. Okay, so this can all be done in Kuzu. Now, once you have this data, you can create a vector index with this call function. So this is creating a vector index called chunks index on the chunks node on the embedding property. That's the syntax. So we'll take essentially all these vectors in the red nodes, and then we will create essentially a HNSW index, which is a very popular vector index design. Right? And now you have the vector index, you can ask k nearest neighbors queries. Okay, so for example, find the 100 chunks whose embedding vectors are close to a particular query vector. That would be a vanilla vector search query. So maybe your query, so suppose a chatbot application that takes a query, what does Alice enjoy doing on the weekends? You can take that and encode it into the same vector space. You get this query vector. And now you call another function called query vector index. And you're saying you're looking for the 100 closest chunks to this query vector index, which is the embedding of this text. What does Alice enjoy doing on the weekend? And you will get essentially a set of chunk nodes and kind of this vector distance that you get, the top 100 closest that you can find. So that's an example of a vanilla vector search. More interestingly, one thing that we can do, which is important, especially if you want more precision and context management in the data, in the vectors and nodes that you have in your graph database, is this what we call filtered vector search, or in literature it's called predicate agnostic filter search. What this means is that you can perform nearest neighbor search across a arbitrary subset of vectors. Okay, so for example, you could the way you would do this is that first you need to identify the subset within which you will do the filtered search. So here I am, for example, saying only among the chunks that contain the word Alice, find me the nearest neighbors of this query. Okay, so then you first do this project graph, which will identify all the chunks that contain the string Alice, and that's essentially just regular kind of sort of record querying. So that's kind of regular Cypher. And then you pass that projected graph, to which you give a name, chunks with text Alice, to the query vector index function, and then we'll return only the nearest neighbors to that query vertex amongst that projected graph you identified. Okay, so here's a more interesting example. So you can say something like, find me the k nearest neighbors to that query vertex, but only among chunks that are connected to the node Alice. So the way you do this is that you first identify again a projected graph through a Cypher query. You say, find me all the chunks that are connected that are mentioned by that mention Alice. So that's the Cypher query, right? Now you've identified all the chunk nodes. You give that a projected graph chunks that mention Alice, and now you can give that to the query vector index, and that will only find you the 100 nearest neighbors that are connected to that particular node, Alice. Okay, so this is extremely important when you want more precision and control over within which vectors you want to do some kind of semantic search in your AI applications, right? So we got a bunch of other features. I can't list all of them here. So you can use Kuzu in many languages. We support a lot of language bindings like C, C++, Python, Rust. Swift actually came in, Node, Go, and Java. We have along with a vector index, we have a native full text search index that implements the BM25 retrieval function, scoring function. We have our own graph data science algorithms that we're developing, and all of this is free under an MIT license. So use Kuzu, and here's a bunch of links if you'd like to take a screenshot, and I'm happy to share my slides as well. So that's my final slide. Thank you very much. One last thing that I wanted to note is that, so this is all open source version. We're not building our enterprise version. So for those people who'd like to go to production with Kuzu databases, but that have a bunch of other production level features, and that will be a server actually that won't be in process. You can join our waitlist. It's on our website. So that's the last plug that I wanted to put in.
Okay, wonderful, great, thank you.
Semih, can I ask a question?
Hi, Brandon. Yes.
Yeah, how are you? Yeah, really wonderful. I mean, I really appreciate your expertise, actually.
Thank you very much.
I was curious, you chose to implement Kuzu in C++, and Neo4j, for example, is written in Java. Have you been able to measure like the just the language aspect, how much that helped you, to use C++?
That's a hard comparison point, frankly, because it would take a lot of effort. Although, interestingly, like 10 years ago, when Kuzu is kind of it was a research project. So there was a question, by the way, on chat. Are all the articles available? Yes, they're all publicly available. You can just go to my website, and there's all our articles on Kuzu and the precursor system GraphFlow, which was just an academic prototype. It wasn't a serious implementation, but that was in Java. And so when we decided to build a serious graph database now on which we wanted actually people to use. So that started 5 years ago, and we called that Kuzu. Then we said, okay, this one needs to be much more performant. So I think it's an obvious choice. Anybody who develops kind of low-level systems, like a database system, needs to pick a language like C++ or Rust these days. So the garbage collection, etc., aspects of Java is not really suitable. I'm not sure what Neo4j thought. Obviously, 20 years ago, they're an older system, and it was a different era. But I'm just trying to say that it's kind of common wisdom that if you care for performance, you want to go for a lower level language like C, C++, or Rust.
Yeah, thank you. Yeah, we had many years of C++ development, and our software used to scream. It'd be so fast.
It does. Yeah. So I don't have a sort of a study that shows that just the language effects to answer your question, but I'm sure it's we wouldn't achieve the same levels of performance.
Okay, very good.
Yeah, thank you.
Thank you. Okay, so I'm sharing my screen, and I'm showing the designer, which is our no-code development environment inside Tom Sawyer Perspectives. And we're going to show how the new Kuzu integrator, which is available in Perspectives 13.3, we're going to show how that is going to work. So we have over here the definition of our application. So our schema, our integrators, different drawing templates, and different drawing views. So we haven't added the data integrator yet. We haven't added the schema yet. We're going to go ahead and do that now. So here we're looking at our schema definition, and you can see there isn't one yet. And so what we're going to do is that when we integrate with Kuzu, we're going to automatically extract the schema from the database. So let's go ahead and do that. We're going to go to Integrators, Add Integrator. We'll choose Kuzu. And then here's where we're going to define where the data is. So we're going to go here. We're going to choose the data directory where the Kuzu data is stored. We'll say choose. We can test the data source. The green check mark tells us that we are now connected to the Kuzu database. And we're going to extract the schema. So first it's going to ask, do you want to extract all of the model element types? And we will. And then we'll be asked, do you want to extract all of the attributes? And we do. So we choose finish. So we've automatically extracted the data and we're now connected to the database. So let's go back to our schema and you can see that it is now populated with the model element types and also all of the attributes. And you can see over here in the drawing view of the schema. So now I've opened up a different version of the application where we're a little further along. I've defined our drawing templates, and now we're going to add our data visualization views to the application and do a view layout of our dashboard. So we're going to go over here to Views, Add View. We'll add a drawing view, and we're looking at a database that has information about movies and the actors that were in them. And so we're going to bring in our actor and movie model elements, as well as all of the edges. So first, let's add our nodes. So for every actor node that we have in the model, we're going to add a node to our drawing. And here I'm going to choose that actor node template. And the same with the movie nodes. And this time, I'll choose the movie node template. And for all the edges that we have in the model, we're going to add an edge in the drawing view. So our drawing view is now fully defined. We're going to add a table view. And this table will include information about the movies. So press OK. And then you choose which attributes do we want to show in the table. So we're going to choose the ID and the title. So our table view is now fully defined. We're going to add one more view, and that is an inspector. And we're going to have this available for all the elements, nodes and edges. And we're going to say include attributes dynamically, which means that the inspector will automatically show all of the attributes that we have for the selected element. And we click OK. The inspector view is now also fully defined. So we're going to go to our view layout, and now we're going to create our dashboard layout. So first I'm going to place the drawing view, and we're going to add the table here. And now we're going to move the table over here to the right, and we're going to add our inspector view to the left. We don't need as much space for the inspector and table, so we're going to bring that down here. And we need less room for the inspector. So now our dashboard is also fully defined. For the sake of time, I have opened the application, which also includes the addition of our query builder and our load neighbors capability. Those are predefined actions, which are available in the Perspectives Designer. So now we can interactively load data. So if you want to see more information, you can see the video, which is on our YouTube channel, which is going to walk through all of the steps that we just discussed. All right, so we have here our Kuzu data, and you can see that we have different node colors. So I'm going to zoom in over here to this part of the drawing. So we have different node colors for our movies and for the actors. So I want to know more about this particular movie. So I'm going to select that particular movie, and I'm going to open load neighbors. And we're looking at our pattern matching load neighbors capability. So here I can edit this node to add certain conditions if we want to know about certain actors, that are from with a particular name or such. We could define that here. But here I'm going to just keep any because we want to load all the other information that we have about this particular movie. So I'll select OK. And it's talking to the Kuzu database. And there we have more information which is loaded. Okay, so we're very excited to announce our support for the Kuzu database in the new Perspectives 13.3 release. Okay. So now let's talk a little bit about the other features that are now available in Perspectives 13.3. So we have made improvements to our modern web client framework, and including with selection and highlighting, and especially in performance when initially loading complex applications. You'll now see a 25% or up to 25% improvement. We've also made several improvements to our circular layout algorithm, and you will see a reduction in the number of edge crossings up to 11% on average. So circular layout highlights the natural clusters which are inherent in graph structures. So we see here, we have one example. And then here is a larger example. And so all of our layouts are available regardless of the integration type that you have. So if you have a Kuzu database, you also are able to use all of the different layouts, including circular. Okay. All right. And now we're going to take a look at our new launch failure demo. This is an interactive demo where you're able to explore different causes of failure that were seen during the space race era. So the Apollo missions and the Gemini missions, for example. So I'm going to select this node called guidance system failure, and we want to know which other missions also experienced this failure. So I've selected that particular error node. We're going to do a load neighbors. So again, here we're going to see our pattern matching load neighbors capability. And I'm going to update any because I want to know which missions also experience this problem. And I also want to know which rockets also experience that same problem. So we're going to add an edge and a node, and we're going to update this to vehicle or rocket type. And so now we have that graph pattern defined. I don't need to write a gremlin or a Cypher query in order to use this capability. Now, if you're curious, we can show the query. And so we just saved ourselves all of this trouble of not having to write this particular query. Okay, all right, so we have our graph pattern defined, and now we choose OK. And that information is going to be automatically located into our drawing view as we see here. So we see which other missions and vehicles or rockets experience the same issue. And then over here on the left side, we see a swim lane summary. We can see which problems were observed. So we have one in each swim lane, and then we can see which missions experienced that issue. Okay, so now we're going to do a different search here. I'm going to select everything in the drawing view. And I'm going to open the query builder, and we want to load information about the Apollo mission or the first moon landing. So I'm going to do an edit. And here, we're going to add a condition. We want the name to be Apollo 11. So we can see here in our pattern matching query builder that we now have this little filter icon showing us that there's a condition that's being applied. And we're going to also add an edge and a node. And I'm going to keep this saying any. So what we're saying here is load me Apollo 11 plus all the information that you have for it. And we press OK. So we can see here how we have the different data types. The different types of data are shown with the different graphics in the UIs that we have defined. Okay, so now more about this particular mission. We can load directly from this application supporting documents and data. So we can right-click and we can show the actual video launch. So for example, if you have engineers that are needing to watch a launch and see that a particular error occurred and maybe there's an extra flame somewhere that it shouldn't be, you can point to the data and say, okay, this is why we know this particular problem occurred. Here's video proof of that. And we also can load supporting documentation. So directly from the application, we're able to load here the mission report as well. So this type of application and approach fits into GraphRAG pipelines. So you need to get more correct information into your LLM. The knowledge graph that we have here helps you do that. Do you need to verify the information that's come out of an LLM? You can also do that here by having the supporting documentation. Okay. We really appreciate you being here today in our special webinar announcing Perspectives 13.3. We very much appreciate having Semih here today as our special guest talking about Kuzu. We also showed how to use the new Kuzu integrator in Perspectives. And we talked about our improvements and our modern web client framework. And we also looked at this new launch failure demo. So Semih, if people want to know more about Kuzu, where should they reach out?
So I would encourage them to obviously go to our website and come to our Discord to join our community. There's always somebody active there answering the open source community's questions. And you can reach out to me at semih@kuzudb.com.
Wonderful. Thank you. And thank you again for being our special guest today.
You're welcome. Thank you very much for having me.
And if you'd like more information about Tom Sawyer Perspectives or to start your free evaluation, please reach out to us on tomsawyer.com. We would be glad to set up a call with you and help you find your best solution. I also want to take an opportunity to have a brief preview of what we're going to be discussing in our next webinar in August. Now, we will be releasing Tom Sawyer Explorations 1.3, and we have support for a new annotations capability, which you see here. You're able to apply annotations to nodes, edges, and the project. We have an advanced panel over here, and as you can see, we have many different categorizations. We also have different filtering capabilities as well, so you can see certain annotations or certain elements that have certain types of annotations. And also, we will be releasing Kuzu integration support in Tom Sawyer Explorations next month. So please join us at our next webinar, and we'd be very glad to see you.